Give it a wave? Apparently not.
Greetings everyone and welcome back. So this is the wand of illumination. A 3D printed wand combined with a flashlight incorporated inside. Utilizing one of the Harry Potter's wand as a model, we have created a new wand from scratch. Inside the wand we have installed a fully operated flashlight circuit. An ATtiny 13A microcontroller connected to a switch that toggles the white 5mm LED makes up the flashlight circuit. A 3.7 volt 50 mAh LiPo cell that we added inside the wand serves as the power source. The TP4056 IC configuration, a well-known lithium-ion and lithium polymer charging IC, is used to charge the LiPo cell. Using the sketch we uploaded to the ATtiny, the user can flip an LED on and off for pressing the switch for 500 milliseconds. If the user presses the switch again, the LED will turn off. The first step in design process was to import an image of wand into Fusion 360 from the internet. We calibrated the length of the wand to be exact 300 millimeters. The idea was to stick to a basic wand shape rather than to try to replicate the asymmetrical details or the wood texture, which would be difficult to print on my Ender 3 printer. With the intention of incorporating a torchlight within the wand, we hollowed out the design and separated it into three sections: the handle, the upper shaft and the lower shaft. The handle part has upper and lower shaft assembly attached in place and mounted together. A little LiPo cell is positioned inside the handle's lower portion, and we have placed a circuit inside the handle part that will house all the electronics. The handle part is split into two halves. On the handle portion, we have incorporated a switch. Once the model was completed, we used a 0.4 mm nozzle with 20% infill and 0.2 mm layer height to 3D print each component out of brown PLA. The process of assembling the upper and lower shaft involved inserting the upper shaft through the lower shaft and securing it with super glue. In this instant, an ATtiny 13A 8-bit MCU is connected to a switch on pin 4, and the load resistance is used to control the current by connecting the LED load directly to pin 0. We also are using a LiPo cell as our power source, and it is coupled with a separate charging IC arrangement that include a TP4056 minimal setup. Also, we will be using a vertical USB port here for charging input for the TP4056 IC. As for the LED, we are using a 5mm white LED made by Everlight. With a forward voltage of 2.8 to 3.6 volt, this high luminous white LED is commonly utilized in torch applications. Its 15-degree viewing angle and maximum forward current of 30 mA make it ideal for our wand flashlight project. We place an order for the white silkscreen LED board. After placing the order, PCBs were received within a week and the PCB quality was pretty great. Over the past 10 years, PCBWay has distinguished themselves by providing outstanding PCB manufacturing and PCB assembly services, becoming a trusted partner for countless engineers and designers worldwide. Their commitment to quality and customer satisfaction has been unwavering, leading to significant growth and expansion. You guys can check out PCBWay if you want great PCB service at an affordable rate and low price. PCB assembly process started out by first adding solder paste to each component pad using a solder paste dispensing needle. Next, we pick and place all the SMD components in their place using an ESD tweezer. We place the circuit on our DIY SMD reflow hot plate which heats the PCB from below up to the solder paste melting temperature, and the components are then soldered to their pads. We then add the vertical USB port and push switch to their location and solder their pads using a soldering iron. Once the circuit was finished, we connected the battery connector of circuit to the positive and negative terminal of LiPo cell. After that, we plug in the power by the USB port and measure the current drawing, which is 0.23 amps, using a power meter. The red LED will glow during the charging process. However, the green LED will turn on and the red LED will turn off when the battery reaches the 4.2 volt. As for the brain of this project, we are using ATtiny13A here, which will be programmed using our previously made Arduino as ISP shield. Here we added the circuit to the programming shield by placing the programming CON6 header pin on the CON6 header pin of mainboard. After installing and setting up the core file, we go to the tool menu and selected the ATtiny13A board. We set the BOD to 1.8 volt and selected the programmer as Arduino as ISP. We then burn the bootloader, which take up to 30 seconds to burn. Once the bootloader has been burned, we select upload using programmer from the sketch menu to upload the sketch into the ATtiny. This is the main code used in this project, and you can find this code along with other details on this project page. Link is in video description. The first step in this main assembly process is to attach two 190mm wire to the white LED's positive and negative terminals. The LED was then pushed inside the shaft assembly, causing the LED to pop out from the shaft's end. With help of super glue, we secure the LED in its place. We now connected the LED terminals to the load terminal or CON2 pad, which are on the main PCB. The circuit is then placed on top of the designated screw bosses, and the battery is then placed in its proper position on the other end of handle. In order to secure the circuit in place, we join it with the handle portion screw bosses using two M2 screws. The shaft assembly is then placed inside the handle part, and the shaft position is held in its place by the other handle part. These two components will ensure that the shaft assembly remain in its place. We use 5 M2 screws to mount both handle part together. The assembly is now completed. Here's the result of this magical build. A working wand flashlight that works. The light is controlled by a switch on the grip of the wand. Here, a white 5mm Everlight LED with a 15-degree viewing angle provide the light. Although this wand cannot be used for magic, the ATtiny13 that is being used here is doing a wonderful job of driving the LEDs. The wand flashlight can be used outside without any issue as a test. Although it's not very bright, the light works, but in the upcoming version, a higher power SMD LED will replace the 5mm LED to improve the lighting. Overall, this project was a success, and I will be preparing a version 2 for improving the light intensity. In addition, we appreciate PCBWay for support of this project. Visit them for variety of PCB related services such as stencil service, PCB assembly service, as well as 3D printing services. Thanks for reaching this far, and I'll be back with a new project pretty soon. Peace out.